Hello, everyone, and welcome to this pre-conference seminar incorporating perceptual models into hydrologic education. My name is Julia Masterman. I'm the Science Education and Outreach Coordinator with CUAHSI. CUAHSI is the consortium of universities for the advancement of hydrologic science. This seminar is the first event of the CUAHSI Biennial 2021, Converging Ideas and Expanding Approaches in the Hydrologic Sciences. This year, during the biennial, we are celebrating CUAHSI's 20th anniversary and hope that you will join us for this virtual conference. It will begin in earnest next week on Monday, July 19th, and will run through Wednesday, July 21st. Registration for the biennial will be open until this Thursday, July 15th. I'll put information on all of these items in the chat in just a moment. The CUAHSI Biennial Colloquium is an exciting opportunity to attend more fantastic talks like this one that we're about to hear, as well as opportunities to connect and engage with the water science community more broadly. Our education and outreach team has been working on putting together a program with lots of different types of events, so we hope that you will join us next week. Before I pass things off to today's speakers, a few logistical notes about this webinar. This webinar will be recorded and posted on the CUAHSI YouTube channel. Secondly, please utilize the Q&A functionality to ask questions. There'll be some time at the end for Q&A and discussion. And if you have any questions about the biennial or anything else CUAHSI related, please feel free to reach out to me, and I'll put some more links on how to engage with CUAHSI further in the chat in just a moment as well. But with that, without further ado, let me pass the mic to Dr. Gordon Grant, who will be introducing today's speaker.
Thank you, Julia, and welcome in whatever time zone you find yourself today. It's really an honor to get to introduce Jeff McDonnell this morning. Jeff has had, by any standard, a remarkable career, and I'm not going to dwell on the details. I encourage you to look at the biography in the CUAHSI program as it lays out his many awards, his achievements, his fellowships, both nationally and internationally. But what I would like to just bring to our collective attention as a way of framing what I think we're going to hear today, Jeff has used his career that started in thinking about where water comes from, how different sorts of hydrologic systems are plumbed, and what that tells us about the evolution and trajectories of these systems. Jeff has used that in his later years as a kind of springboard for helping us think not just about how water works, but how we collectively as a community go about studying water, and how we go about thinking about not just the subject itself, but how we train people in water. And he's used his remarkable platform as a way of helping us understand where our field is, where it's been, and by extension, where it's going. He's used his pulpit to help people think about how we educate, how we build community. And in all of that, he's really becoming what I would refer to as a statesman of hydrology, a statesman for our field. So what you're going to hear today is, I think, very much in that vein. It's part of a book that I think you'll hear more about in his talk. But I'm delighted to have him kick off the CUAHSI Biennial, and very much look forward to hearing what he has to say. Jeff, up to you.
Just share my screen. Wipe away a few tears. Thank you so much, Gordon. That was over the top kind of you. Oops, sorry. You'd think by now I'd have this down so effortlessly. Julia, can you see my slides? Excellent. Well, Gordon, thanks again so much for those overly kind remarks. And what I'd like to do today, given the hydrology education theme, is to talk a little bit about the need for perceptual models in our hydrological education. So that's what I'd like to do for the next 40 minutes or so. And the roadmap for the next 40 minutes is to maybe give you a sense of what the problem is, and then define, what is a perceptual model, why it might be important in hydrological education, and how we can incorporate these perceptual models into our teaching. So this is the roadmap that we're going to follow here going forward. I want to acknowledge that there are a couple of very recent papers on this topic, less on the education side, more on the modeling side, regarding perceptual models. This is one on a preprint server led by Thorsten Wagner. It's, I think, in press perhaps now in Wire's Water, realizing the value of perceptual models and knowledge accumulation. And here's one that came out in April by Keith Bevan and Nick Chappell at Lancaster, Perceptual Perplexity and Parameter Parsimony. And that's a real tongue twister. But these papers I really recommend as it relates to this theme I'm talking about today on perceptual models. They're very, very good. Now, what's the problem? I guess, I've been teaching in a university context now for over 30 years. But in the last 12 years, together with Keith Bevan, Rick Hooper, Dorte Tetzlaff, Chris Soulsby, and now David Hanna and Jan Seibert, Ilya van Meerveld, Stefan Kraus, I hope I haven't forgotten anyone. We've delivered this Catchment Science Summer School. And what I've noticed in the students that have come through the class, we've had maybe 350 or so over the last 12 years. We get about 30 a year coming to this, mostly from Europe, but not exclusively so. Not just their training, but their focus for their PhD work is going ever more model-centric and less field-based. And this is consistent with, statements that have been made in the literature. Others have, talked about. This is one I like from Mike Kirkby. Well, I don't like it. It's quite sad, but it's true. As computing power becomes cheaper and fieldwork more expensive, there's a trend away from fieldwork and towards more complete dependence on simulation. And certainly we've seen this in the Catchment Science Summer School, I think. And this fits with what we see in the literature. This was a little piece that Tim Burt and I did on the right, showing percent of papers published and the model-based versus the green field-based. And I've had senior colleagues tell me something like this. This is something told to me by a senior colleague. Today, students often think that all the process discoveries have been made and that really all that's needed now is to parameterize them in new places at ever expanding scales. And this is really not the case. And I think maybe our teaching has to do with this state of affairs. So this is what I want to really get into today as we talk about bringing perceptual models into our teaching. So what is the problem? If the catchment was all, overland flow, then what would we do? Well, it'd be some kind of diffusive wave equation and, a Manning's N selection for roughness, and Bob's your uncle. We'd have no problem with stream flow at the catchment scale. Or if it was just steady state groundwater flow driving stream base flow, then likewise, we'd have a 3D, Darcy or Darcy-Richards if it was variably saturated, and we'd be good to go. The problem is that it's not that. We have variable saturation, spatially variable soil depth. It's not just the soil, but the critical zone effort has shown it's what's below the soil, the weathered rock, the saprolite. It's the ubiquity of preferential flow. It's the extreme scale dependency of our runoff processes. It's things like celerity velocity differences, unknown boundary condition, and this list could just go on and on and on. And this is why I think a perceptual model is needed, because we need a way to somehow wrap our heads around that long list that's not easily measurable. So what is a perceptual model? It was first introduced, as many things in hydrology have been over the last 40 years, by Keith Bevan. This was in a IAHS conference proceedings back in 1987. He's kind of updated the definition in his modeling textbook. This is from the Rainfall Runoff Modeling, the primer text that came out first in 2001, I think. It's a summary of our perceptions of how the catchment responds to rainfall under different conditions. It's very personal because it's based on your training, what you've read, what you've measured, what you've done in the field, typically. My own definition of a perceptual model, it's kind of a compression algorithm for a place. It's like Agatha Christie's Murder on the Orient Express. So it's not, one culprit, but a multitude of culprits. So if you recall, and many of you are probably too young for this, think of the detective Hercule Poirot, and it's trying to bring as many tools together through a process of elimination to get at the culprit or multiple culprits. And I think this is the thing that I'm hoping we can bring more into our education. I'm going to try and make an argument for today. So it's a personal narrative to really, in my case, give an account of age, origin, pathways of water, how catchments store and release water, and it's at the spatial and temporal scale of interest, because things change depending on the time and space scale that you might attack it. And now, Gordon mentioned some of my early work. This was my first WR paper in 1990. And the paper was a real challenge, not because of the paper per se, but what to call it. So I think when I submitted it, I called it a model for old water discharge through macropores. Well, reviewers did not like that. What? This is not a model. Remember, this is 1980. And then I thought, well, surely they'll accept a conceptual model for old water discharge. Nope, that wasn't. And so I arrived at, I guess, a rationale for old water. And it's gotten a lot easier lately. You're seeing the word perceptual model. There's been discussion of why and how it could be important. And it's like I think it's Picasso that said this: if art is the lie that helps us see the truth, then a perceptual model is really the lie that helps us understand the catchment as a system. And that's where I'm going with this today. And these perceptual models can evolve and do evolve and should evolve. And one example is the Mai catchment in New Zealand, where many groups over the years have studied the hydrology of these hill slopes and found these mechanisms to be different depending on the tools used, kind of ultimately arriving or constraining a perceptual model. There's a paper that came out just months ago led by Brent Allenbach, Rick Cooper, and others from the Panola watershed, looking at its evolving perceptual model. This evolution is something to be celebrated and discussed, and this is very healthy, I think, for our improving understanding of our system. I mean, really, they are hypotheses to be posed and rejected as null hypotheses. And I think this is a way to maybe deal with the complexity of our systems in our teaching. So why are they important for hydrological education? Well, the first thing is, I love this quote by Howard Cook. We'll talk about him a little later. The calculation of runoff is the central problem of the science of hydrology and involves all the phases of the hydrologic cycle. So apologies for those that are studying other things, but this is the very biased take I'm having for this talk and this discussion. But of course, I recognize that catchment hydrology is one element. At AGU hydrology section, of course, it's just one of our technical committees of the 13 or so that we have. But this is the focus I want to talk about. And let's think about the teaching of runoff processes, if you like, going back to the first manual of hydrology by Beardmore. This is a great read if you can get your hands on one. And it's really here, it's just as a percentage of rainfall. And this is a whole series of case studies in part 4, rainfall and evaporation. This is really, again, this is what I've spent my pandemic doing, reading these old books and periodicals. I'll tell you why in a moment. If we advance a little bit further in time, this is 1949, Weiser and Brader, hydrology. Interestingly, Robert Horton was to be a co-author on this, but he died before it was finalized. But here they're very influenced by Horton's work in the 30s and early 40s. And now runoff is rainfall rate above soil infiltration capacity. But again, a very much over the whole catchment viewpoint. And of course, if we advance to today, a book I love by Wilf Broussard, really an exceptional textbook, talks about partial areas, meaning infiltration occurs only on, excess occurs only on areas of the catchment. This is for runoff. And of course, Wilf acknowledges other forms like the variable source area concept and other things that we've learned in terms of different mechanisms beyond infiltration excess. And what I really love about this book, which probably takes a more nuanced view of runoff generation than almost any hydrology text, meaning a general hydrology text. There's just a couple of things from one page in the book talking about each drainage basin almost behaving in many respects as if it were a law unto itself, and how it's often difficult to quantify the different mechanisms that produce the change in stream flow with time. The decomposition of an integral into its constituent parts, that is its inversion to obtain the integrants, is like unscrambling an omelet is not a simple matter. Beautiful, beautiful. And you know, Wilf gets it, of course, but this is very challenging ground, I think, from an educational point of view. And in fact, maybe it's like this. You know, I'm not on Twitter or any social media, but occasionally I'll look at Twitter. This is probably the best tweet I've ever seen. This is Elon Musk talking about when there was so much discussion about UFOs with the release of files in the United States, camera resolution, UFO picture resolution. Maybe some of you have seen this. And the simple statement, the strongest argument against aliens. And it's a bit like this, I think, in hydrology with our teaching of perceptual models. We've got models becoming ever more detailed, ever more amazing visualizations, ever more spatial completeness, running a Darcy-Richards solver at the scale of the continent of the United States. And yet, the perceptual model that maybe underpins these models has been kind of stuck in the 1970s, I might say. And this is true of what we see in so many books that we have. And this isn't a slag on textbooks at all. It's just thinking about how we can maybe supplement what we teach by adding in some more formal discussion of perceptual models. So it's kind of like, I'm obsessed with Elton John, Billy Joel, the Eagles. You know, I'm stuck in the 70s with my musical tastes, and we're kind of stuck in the 70s with our perceptual models of runoff generation. Again, acknowledging that Broussard in his book takes probably the most nuanced book or look at this. And there are other texts written by people like Dave Tarbotton, his rainfall runoff processes text is extremely useful from, I think, the early 2000s. There's other obvious exceptions, but I'm talking about generally. So how have perceptual models advanced beyond the 1970s? Laurent Pfister and Jim Kirshner had this very nice paper a few years ago in WRR, part of the debates series, and they identified 4. And one was the strong damping of isotope composition of hydrogen and oxygen in stream water compared to rainfall. This so-called old water paradox, if you like, preferential flow in both saturated and unsaturated media, and the fact that that drives the bus in so many instances. The spectral scaling of tracer time series, and how that's not what one would expect with mixed box models, and the 2 water worlds hypothesis, this idea of eco-hydrological separation revealed by isotope tracing of plants and soil water. Now, this list could be longer, but this was just the one that they generated. But this is virtually absent, I would say, in our textbook teaching. So how might we incorporate this in our textbook teaching? Well, one way is to have a textbook focused on it. And I told Gordon before the call, this is going to be some shameless advertising here, but also more importantly, I really would love people's critical feedback. This has been my pandemic passion project for the last 6 months anyway, and it's probably got another 6 months to go. But the hope is to get your critical feedback in terms of maybe what's missing or how I've missed the boat on some topics. So I want to just step you through a few elements of it. It's broken up into 4 sections, starting off with an introduction and maybe one hydrologist's perceptual model. And I lean on Keith Bevan, my hero in this first little inset that comes with the chapter. And over the last 6 or so months, I've had the real privilege of talking to my kind of hydrological elders, with apologies to Rhett Jackson, who I think is maybe 1 or 2 years younger than me. But this has been very, very helpful to kind of get my story straight in terms of the early literature. And chief among them was Tim Burt, who just before the pandemic took me on a tour of Bicknoller and Slapton and East Twin Brook, these famous research catchments in England. And this has been very, very helpful as well. But conversations with these people have really helped me kind of get my thinking straight, because, particularly the early literature, from the early process work, let's say, of Horton, to when I really got going in my teaching career in, say, 1990, it's difficult to track. And I can really empathize with why maybe we've, the way we've described it previously in textbooks, because it's quite a circuitous process. And these conversations have helped immensely with me trying to get my head around how we've made it from one period to another. So the book starts off with what I call the shortest history of catchment hydrology from 1930 to 60. Just looking at the chapter titles, don't worry about the content. Of course, talking about how we've gone from infiltration excess to partial areas, and then how we went from subsurface storm flow to so-called dynamic areas, what it was called even before it was variable source area concept. This is the period 1930 to 1960. And of course, there's a lot of great stuff that's largely forgotten about in our hydrologic teaching. This is an incredible diagram from 1938 by Charles Hirsch at CUAHSI Hydrologic Lab. And it would almost rival a critical zone brochure right now if the graphics and the fonts were a bit different. You can see a forested side and a non-forested side, what that means for regolith thickness, thinking about the water table, the unsaturated zone. There was maturity in thinking even back then that we often don't incorporate into our kind of thinking or our teaching materials, I guess I should say. And then this is followed by a longer history from 1960 to 1990. This was when I think, so many changes occurred with the first international hydrological decade, and then the advent of stable isotope tracing. So it deals with the variable source area concept in its different fashions. Some letters I've got hold of between Hewlett and Leopold that I think I want to weave into the teaching, and we can all weave into the teaching. And much forgotten field work. This is some work that Tony Jones from Aberystwyth in Wales has turned me on to. That's really been helpful in terms of describing some of the early field work. A lot of it is long forgotten. These letters that I mentioned are just teaching gold, because it gives you insight into thinking of the day. I think there were 4 of them between Hewlett and Luna Leopold, and it related to what was being published in the literature, ideas, maybe credit for ideas, and it's just exceptional insight into the thinking of the day. And this I think can be very helpful to bring in to kind of somehow personalize this so it's not ancient history, that there are personalities involved, that everyone had an agenda, You know, Horton had an agenda, Hewlett had an agenda. We all have agendas, even today. And for the student to kind of understand that personal side of the development of our discipline, I think can be very helpful. And then, of course, how stable isotope tracing kind of changed the game. And then the race to explain these kind of old water effusion details, which ended, let's say, towards the end of the 1980s. And of course, this is something I think that has been pivotal and is not discussed much. You know, there's one book that discussed this in great detail, and that was Alan Rhoda and Harold Grip, and water's journey from rainfall to the stream. Unfortunately, it's in Swedish, so it's a little tough to follow, but I think Kevin Bishop has been involved with the translation. Anyway, I think this is so important to somehow make the shift to more modern understanding of perceptual or more modern perceptual models, because now they all hinge on these differences between celerity of the hydraulic potentials and the velocity of the water molecule and the other characteristic velocities. And tracers, of course, really brought this to the fore. And I think what no textbooks ever confronted that I'm aware of is this kind of behavior. Here is the first deployment of a laser spectrometer next to a field station. This is at the H.J. Andrews in Oregon. And what you're seeing on the top box is rainfall and runoff. And on the x-axis, of course, is time covering 3 days. And what you see are some bursts of rain and a response of the storm hydrograph. This is watershed 1. And then what you see in the second 2 panels is on the y-axis, deuterium and O18. And the blue is the isotope composition of the rain and very high frequency. This was at about 20-minute intervals, I think, through this period during this deployment. And you see it for the blue for the rainfall for the O18 and deuterium, and look at the red. The red is the stream and high frequency. That is still our greatest challenge. Basically, the stream is saying, I see no rainfall at any time through this event. And meanwhile, look at that red hydrograph in the upper that's responding very rapidly after the initiation of the second pulse. So no evidence of rain, even at the peak of the rain event. What the heck is going on? Well, this has been the focus for the past 30 years of perceptual models. And I think this is what we need to bring into our teaching so that we're maybe a little less enamored with visualizations from models, and we can ask more critical questions in terms of, well, does it explain this and this and this that is now so crucial to our perceptual understanding? Now, we talked about updating perceptual models. This is something I found at the National Archives at the last time AGU was in Washington, D.C., again, pre-pandemic. Others have looked at these boxes. This is something I found in one of the boxes, and it's a letter from Horton to Howard Cook, who we quoted from earlier. And I just want to read you a couple of passages, because I think this can be very helpful in our teaching, again, to humanize and to provide perspective that science is about overturning ideas, and that one does not want to hang on mercilessly to something that maybe is not correct, and we're all going to be corrected at some point. At our last meeting in Washington, you brought up the question of high rates of groundwater flow alleged to occur in the upper Ohio and possibly New England drainage basins. Also of the possibility of instantaneous outflow of groundwater following infiltration as a result of wave translation. I'll just go on, this is the last 2 sections. I am satisfied, however, that this matter of ephemeral groundwater has been greatly exaggerated. He's talking about that in the context of stream flow, and overemphasized in some quarters. And I wish to point out the following. And he goes on to say, as to instantaneous outflow of groundwater as a result of wave translation, I'm unable to see how groundwater in any large quantities can occur in excess of that provided under the conditions described above. Since water under those conditions, all the energy available is consumed in overcoming groundwater friction. Possibly the inventor of this theory will suggest some extraterrestrial source of energy. Again, it's just great because it brings in maybe to our teaching that new techniques like the isotope tracing that happened long after this letter was written in February 1941 can show rather different behavior and openness to that. Updating, evolving our perceptual model is just so crucial to our understanding of systems. The third section is more, for me, a personal history because I've lived and worked this. I start off with some example catchments, talk about some of the things the community has learned in the last 30 years, focused on thresholds, connectivity, and the extreme scale dependency of runoff generation. So what we think about at the hill slope scale can be very different to the headwater catchment scale, and how to bring this into our teaching, connectivity, thresholds, hysteresis, storage, excess. The idea that it's really not rainfall runoff, it's storage release, it's storage excess, and that everything is so thresholdy. If we look at on the y-axis, storm flow coming from a hill slope and rainfall on the x-axis, and each dot's a different event. This is very characteristic of what the literature generally is showing. So again, not this smooth, linear, reaching up slope of saturated areas from 60s and 70s, but something much more nonlinear, with these characteristic forms of nonlinearity really deriving how systems seem to respond. And then going from hill slope to headwater scale, headwaters to larger catchments, and the various things that appear when you go out to larger scales. Again, the extreme scale dependency. That runoff generation is really at the scale of the beholder. And then lastly, looking ahead at the future and maybe thinking about the similarity of runoff forms rather than always talking about the differences. Maybe there's some new theory that could supplant the variable source area concept or complement it. The measures for forming a perceptual model, what they might be in this day and age. And then finally, talking about the other outflow from catchments, perceptual models of where plants get their water, and moving our catchment water balance beyond just an accounting model to think about an age-based view of the water balance. And that's how the book ends in terms of not only how much, but how old. And I think these are really two equally important factors if you're dealing with stream flow in the order of decadal time series, or are your plants using yesterday's rain or taking water that could be a few decades old from a deep vadose zone? Is your groundwater 100 meters down in your catchment that's still active? Is it centuries old? Is it thousands of years old? Is it fossil water pre-Holocene? I think this asking how old it is as well as how much it is of it there is really maybe the future, and helps to force this perceptual model integration into the way we describe our systems. All right, well, let me try to wrap up. I guess I've tried to describe what a perceptual model is, going back to the Bevan 1987 original definition, and why it might be important for hydrological education. Interestingly, this is consistent with what emerged from the very recent CUAHSI catchment observatory set of seminars that happened through the winter. This started, I think, in February and went through much of the winter. And these catchment observatories, which are also culminating in a special issue of hydrological processes led by Steve Sebastian, along with others that are working with him, resulted in over 100 submissions to HP in terms of describing these catchment data sets. And then this was described in the CUAHSI effort. And at the end of the CUAHSI series of calls, what came from the community, I had no involvement in shaping this statement, but I was so gratified to hear it in a way, is that what should we do with these 100+ research catchments? The most important thing we can do, this is what we heard from the community, would be to collect a mental model of each person's catchment, meaning how he or she thinks that their system works. That was interesting, and it gave me fresh pluck in terms of continuing to push ahead with my little effort. And then lastly, I guess, if you read this Thorsten's paper with his many colleagues, it, I think, can help do what they're advocating, and that is, from a modeling point of view, really putting perceptual models front and center in the model development testing framework, as you see in this diagram from their paper. So I commend you, or commend that paper to you. But I think this type of educational effort would help in that regard. And then lastly, I guess, again, back to the shameless self-promotion here, this is a book I hope will come out, published by Oxford sometime in 2022. And I'll leave it there. Thank you very much. I'll stop sharing my screen.
Thank you very much, Dr. McDonnell. If there are any questions from the attendees, I would recommend that you use the Q&A function in Zoom, and we have some time for some Q&A discussion.
Oh, I just saw something from Jan Seibert saying that there is a English translation of Alan Rhoda's book. That's great. Well, you know, Julie, if there aren't questions, I would certainly welcome any emails from folks in the coming days or weeks if they have any critical comments on the book contents. I know I went through it quickly, but I would love to hear what I'm missing, maybe a take I'm not thinking about in terms of framing that discussion. That'd be really helpful. I think Gordon's got a question there, Julia.
Jeff, can you hear me?
Yeah.
Great. Great talk. But I want to play devil's advocate for just a quick moment.
Yeah.
And it's based on my personal experience with the Critical Zone network. And I was on the Science Steering Committee. And one of the things that we would, every time we'd get together as a collective group, the Science Steering Committee would pound on the table and say to each of these critical zone sites, so recall these are sites where everything is getting measured and people are entranced by everything from the top of the vegetation all the way to the deep bedrock. And we would say, we need a cartoon of how your catchment works. We need that conceptual model to help us compare and contrast, to put these on the wall so that we can really see how these places are different and how they're the same and what are the commonalities. And it sounds like this was very much what came out of that recent seminar series as well.
Yeah.
It turned out to be very difficult to do that. And it wasn't because people were unwilling, but it turns out, I think, that it's a taller order than just drawing box and arrow diagrams. So I wonder if you could speak a little bit to what you see the impediments, but also the opportunities are in crafting conceptual models that apply to different parts of planet Earth. Thank you.
Yeah. Well, you know, we all measure things and do things in different ways. So there's no standard operating procedure. There's no agreement as to, you know, even the devices we use, let alone where we place them. So each system is kind of treated in an ad hoc way, and that's a problem. And we've seen this when we've brought groups together during the IAHS pub movement. We had a group, we called it the Slope Intercomparison Experiment, SLICE. Everyone who trenched a hill slope, we brought together at the Andrews. There was about 40 of us. We're really super hopeful, like perhaps in the critical zone group, But we realized we all did things differently. Some had isotope data, some had some chemistry, some focused on 3D recording tensiometers. And in the end, we didn't really have anything objective to intercompare. Somehow, I think it comes down to agreement that, you know, if you have this is one of your classic diagrams, Gordon. There's a blob and there's three axes, one here, one here, one here. I call it the Gordon Grant blob whenever I show it. And, you know, we need to agree that there is a minimum number of measurements necessary to characterize a watershed. Rick Hooper said this in 1992 when we wrote our first NSF proposal to work at Panola. And I think those measurements are integrative ones. So just like the stream hydrograph, you know, rainfall runoff ratio, whether that's a quick flow measure or runoff ratio, that's vital. Another is old water, new water for me. Old water, new water, along with runoff ratio, now we're getting somewhere. And then a third axis in the Gordon Grant, you know, blob, which is the blob of understanding, truth, I don't know, is the mean transit time of that water. Again, many ways of coming at it. It's a hotly discussed and researched topic, but now when you bring together the runoff ratio, event pre-event, plus the mean transit time, now you've got a way to, you know, pin things down. Now you've got a way to say something, and that is something we can all measure. It's integrative of all of our catchments. We can collect them at different scales. I think in addition to all the probing we're doing, I think we should agree that, you know, at least those three should be everywhere if we're going to say anything about how our system relates to another. Then, of course, there's all the many other things one could supplement. But, you know, for too long, I think we just rely on Boudico. Are we water limited, energy limited? Well, that's such a coarse binning of a system. Those kind of measures, at least for me, are really effective for perhaps doing what you're wanting to do, Gordon. Because you quickly then would see, do you have a big spongy critical zone, or is it very dense rock with no, you know, little movement? You might have even similar runoff ratios and similar old new water, but your transit time will be radically different. Yeah. Julia, are you there?
Yes.
Okay.
Here's a question from the Q&A.
Yep.
How do you think hydrology and perceptual models would have evolved if computers had been more powerful already in the 60s?
You know, my gut reaction is it would have made the situation even worse. Again, I go back to the Kirkby, you know, almost complete reliance on computer models. I think it's just lulled us into such a false sense of security in terms of our understanding of how we think our systems work. And this has been the stunning value, I would say, of the critical zone. This isn't model bashing, but it's just to think about, you know, what is the model structure and how that relates to our process understanding. That's often a real mismatch. So I'm not sure that would have helped us.
Interesting, yeah.
Here's something from Rick Hooper. I'm not sure everyone can see it, but perhaps I could read it, Julia. Jeff, fully agree. The challenge is, when are new perceptual models ready for prime time? Show differences in predictions between Darcy Richards and data. We need boundary conditions to get threshold behavior. How we calibrate a model beyond experimental catchments. Yeah. Yeah, and that is a real challenge. And again, I think why critical zone effort has been so commendable, because it's really put the focus on those boundary conditions. But as again, Keith said, I think in a 2006 paper, the Holy Grail paper in Hess, the boundary conditions are the science. And the sooner we can embrace, all agree that that is the case, that will make life, I think, much better for all of us. Gordon's saying we need falsifiable conceptual models. Absolutely, and that's why I think the evolving perceptual model, if that's what you mean by a conceptual model, is so important. We need to be able to reject them, and that's a good thing. Mm-hmm.
Another question from the Q&A from Courtney DeVittorio. I apologize if I butchered your last name. Really interesting and inspiring talk. Have you considered engaging industry in this effort? From informal conversations with stormwater engineers, I have appreciated how they incorporate site visits in developing and calibrating their models, and they might have some interesting perspectives.
Yeah, it's a good question. You know, back a long time ago, I worked a lot with the City of New York and the Department of Environmental Protection on stormwater, and they were using models like STORM and SLAM and SWIM, and we were doing process studies to understand when, say, a lawn in Westchester County transitioned from one that could infiltrate all the rainfall to those instances where it turned into something parking lot-like because all of a sudden the infiltration capacity was exceeded. Where I've been involved with industry lately is the mining industry, who need to create mine covers, basically hill slopes and catchments on top of waste rock or material they want covered and isolated. And they build these based on 2D, 3D, finite element, finite difference models. And they work beautifully in the first year or two, but then what happens? They get vegetated, preferential flow develops, and within 5, 10, 15 years, now they're behaving very differently to what the model said it would do when it was first created. When the material was all packed to the same bulk density that was given to the model. And showing how those systems evolve can be very helpful and develop kind of realness associated with the biological changes that happen. That they've been very receptive to that, because of course for long-term closure they need to understand that, but that's very difficult to ever predict up front in a model exercise where you're designing the hill slope to function naturally.
Interesting, yeah. Taking a bit of a pivot with this question, we have an anonymous question. I think it's a fascinating idea how to humanize the history of hydrology and how ideas evolve. However, I was struck by how many of the giants of hydrology that were highlighted seem to be white men from the Western world. Have you given any thought to what this might signal to students reading this textbook, and as to who belongs or who can contribute to ideas in hydrology? And to that end, do you have any plans to discuss the role of women, BIPOC people, and non-Western thought to the evolution of ideas in hydrology?
Deeply, yeah, that's been something I've talked about with several, not necessarily the ones that I showed there, although each of them I asked who they knew working in the field during their careers or were aware of in the literature, in the field. And you know, the field has evolved so much. My main collaborator from the day I started was Carol Kendall. But you know, in the USGS, in terms of the National Research Program, and in universities back in the late 80s when I started, the demographics were really very different to what they are now. And usually when I'm doing the teaching in my Aberdeen or now Birmingham course is to show that maybe, you know, the dominance of white male involvement in those early studies, but then to show a slide of today's catchment hydrology and the diversity that we have, and that we're going to look at these early papers. Some were done in you know, in Japan. There's some early Chinese literature that I try to cover, but I guess it's trying to somehow acknowledge different ways of knowing, maybe, or the emergence of different maybe countries or scholarly traditions and when that started relative to the literature that exists. I guess that is definitely not not representative of things currently. But that is the history of our field, and that's what I'm trying to quickly tell as I ramp up to more current understanding of our systems.
Thank you. One note to that end, this year at the second part of the CUAHSI Biennial happening next week, we have a new named lecture, the Florence Bascom Lecture, who was the first woman to join USGS long ago. So we're excited to be honoring her with a new named lecture that for the first time this biennial. So
that's great.
Tangential, but
no,
thought I'd mention it. Another related comment from Kevin Bishop. I have a question about how socio-hydrology might fit into your history of hydrology. You emphasize the human aspect of science so nicely in your presentation, but water itself has a human, political, and power aspect that socio-hydrology has picked up on. The controversy around saturation excess flow between Dunn and Hirsch, which relate to the implication for pesticides pollution, for instance. Will there be a place for socio-hydrology in your book?
You broke up there just a little bit at the end, but I think the short answer is no. No, I'm going to focus on natural systems and maybe the work that's gone on in that regard. So the short answer is no. Maybe I could read a question by Jay Zarnetsky at least in my chat. Does the book attempt to address or bridge the clear and present goal of many students, their interest in learning new aspects of hydrology and what the tools are they will need in the workforce? Will they be doing outside of much of academic versus the learning goal of making sure they understand the history and evolution of conceptual models that's are central to solving clear and present issues using tools and data in hydrology? Yeah, no, probably not, Jay. Again, I guess what I'm thinking about is not a textbook that would just be a replacement for a general hydrology text. No, we need that. I'm talking about something at the grad level, could be used possibly in a class, maybe not a class. Maybe it's just a grad text to be read by those that are, maybe doing hydrological modeling or wanting to understand the nature of processes that are acting in our catchments. But I guess I would hope that it would make someone going off into consulting and using models a more critical user of models, understanding how they might relate in terms of their assumptions and model structures to how we think we understand the hill slopes and catchments to work.
It looks as though we have one last question open in the Q&A, and we only have 5 minutes left, so this is perfect timing. Would you comment on the perceptual model applying to diverse, for example, glacier, tropical, continental, temperate, mountainous geology and soils, steepness, types of catchments? And if the education of hydrology should be place-based or generalized perceptual models?
Mm-hmm. That's a good question. 30 years ago, there was tropical hydrology, and it was seen almost as something so fundamentally different that it existed in a whole different plane. People like McDonnell and others who were Helmut Elsenbier, Samporno Brunzil. I'm trying to think of people working back then. It was almost as though these tropical systems were kind of a type of system unto itself. Fast forward to today, and I guess what we realize that there's really a continuum of processes, some of which are more active in places than others. And I think we're moving away from that thinking. It's really mechanisms that can be thought of universally in some sense, but it's really maybe dominance of certain things. So in a tropical setting, maybe it's more intensity of the rain or the deep weathering of a profile, but essentially the kind of filling and spilling or other kinds of mechanisms are surprisingly similar. Certainly I find that in my travels going to see some of the work by Giova Mascara and his group in Cuenca and Ecuador, and realizing that this is almost identical to what Dorothee Tetzlaff's been looking at the Brundtland Burn catchment in Scotland. And those are two radically different systems. Or the group Fuquin Tian at Tsinghua University, his catchment just outside Beijing, that is almost identical to the kind of Panola work where Ilya Van Meerveld did her PhD work in terms of hill slope behavior on granodiorite weathered granite hill slopes. So I don't know. I guess I'm moving more and more to to thinking about not everything in a kind of a binned regional or geomorphic setting, but looking for commonality and what might weight more heavily in one place versus another.
That's very fascinating, and I think a great place to wrap it up for today. Thank you everyone for joining us. Once again, this is the first pre-conference seminar for the CUAHSI Biennial, which will be starting next week. Thank you for joining us, and I hope to see you next week for the Biennial. And a huge thank you to Dr. McDonnell for this lecture and talk, and for Dr. Grant for being our ringmaster for the beginning here. So thank you all. Have a good rest of your Monday. Goodbye.
Thanks very much.